Good evening to all. Welcome to the day 5 session of our certification program on machine learning and GenAI. So today you all know today is completely question and answer session. So whatever we have learned today we are going to just I'm going to clarify all the doubts. And you can ask me, you can give me directly here in the chat box. You can whatever doubts you have, you can post it in the chat box. So here I can see that as question and immediately I'll answer. You can post anything. So before that, I just want to read the feedback sessions of yesterday's class. So almost all the same things, same feedback I got like all the 4 days back. So, so everything is, all the positive feedbacks I'm getting. So I'm really happy that you understand, you're able to understand all the concepts of machine learning. And some people are asking, repeatedly asking to share the PPT and the links. Anyway, all the collab links and data sets we have already shared you in WhatsApp channel. So I already told you whatever, you want to access all these things, first you have to join in our WhatsApp group. That is a WhatsApp channel. So you have to go into that WhatsApp channel and you have to ask some questions. And more thing, people are asking me to concentrate on more hands-on sessions. So most of the comments are like completely concentrate on hands-on session. So if you see yesterday's and the day before yesterday's class, after teaching a topic in theoretical, mostly 10 or 15 minutes, I'm going to teach the basic concept of a concept in theory mode. And then we are seeing the same concept in practical way also. So mostly everything I don't want that, only people should have a completely hands-on concentration. If you don't know the basic of that program, suppose if you don't know what happens in linear regression and directly you are learning the code of linear regression function and how to use the linear regression function. If you don't know the basic understanding of linear regression, if suppose you want to do a new project on linear regression, that you can't do. It's just by having the code. That I don't want. That's why first I just explained the basic concept of linear regression or whatever algorithm I'm taking or optimization techniques like PCA and gradient descent, all these things. I just want you to understand the basic concept first. Then coding anyway, the basic coding anyway I'm going to show here. I already showed you yesterday in class also. The improvement depends on how you understand the basic concept. So that session will be divided in equally. Anyway, in deep learning, there won't be any much theoretical part will be there. So everything we are going to do with the hands-on session only. Mostly on Monday, mostly we'll have some 15 or 20 minutes will be there for the theoretical class to understand what is the basic mathematical statistical formulas or what do you mean by a scalar tensor, what do you mean by layers. All these thing concepts will be it will take some 15 to 20 minutes. Then we'll go to the hands-on session only. And of course, yesterday I promised you to I'll give you the reinforcement learning algorithm Q learning. One concept we left behind from past 4 days. So that anyway on the Monday starting itself, I'll cover the reinforcement learning first. Then we'll jump on to deep learning because deep learning we got almost 3 days neural networks and different types of deep learning we are going to see. So plenty of time is there. So first I start with the Q learning concept and then we jump on to the deep learning concepts. And one more comment I want to stress here from the feedback is the course material. Course material, as I said in the previous session also, actually I'm doing the PPT, complete PPT I'm doing in, in a single PPT. It's not like a day-wise PPT. If you can see, that from the starting day 1 to day 8, day 10, I mean day 9 up to 9 days, we have the sessions, and of course on the 10th day again we have the test and Q&A session. So what I'm planning is on 10th day I'll share you the complete PPT. Then you need not to search what is day 1, day 2 PPT. So everything will be there in complete machine learning and deep learning and GenAI concepts completely in one PPT. That will be useful for your future reference. So then that's why I'm not sharing now, because if I share you, it will be confused a little bit. So once I complete the complete course, then I'll share you the PPT. The remaining links and everything, datasets we already shared you in your WhatsApp channel. And if most of the people are sending me your mail IDs and asking me to send the links into your mail IDs. See, that is very, completely impossible for us. Actually, it's so many mail IDs we are getting to send personally. Sending the links to you is a bit difficult. So please register in the WhatsApp group, WhatsApp channel. There you'll see all the links and day-to-day quiz programs, everything we can see. So please register in the WhatsApp group. And now I just want to discuss the quiz programs, whatever we had in the previous sessions. And I want to clear what answers you have kept and what is being where you did the mistake. All these things I want to discuss today. And if you have any doubts, any questions, you can ask me. Then we'll end the session by 7:30 today. It's not for 3 hours. So first we'll go to the quiz one. Just open the quiz one second. First, on the day one, we have completely the topic is about data pre-processing. Completely about data pre-processing. So on the day one, we had first question is, which of the following is not important in determining the data quality? So the in determining the data quality, options are like accuracy, consistency, and completeness and database. So which one is not important? So data quality, we have seen so many factors which will influence the data quality. On the day one, we have seen what are the factors which will influence the data quality. In that, accuracy is must, and the consistency is must, and completeness is must. Because if those three are not fulfilled, then we can say the quality is very bad. So the remaining thing is database. So that is the answer for the first question. And second one is data cleaning involves filling in missing values. Is it correct, true or false? So data cleaning is nothing but yes, filling the missing values. That is one option we have given our data pre-processing thing. So data cleaning will consist of three parts. One is removing the noise, removing the missing values, ignore the missing values, and all this and of course removing the missing values, or whether you have to ignore that missing value or you have to fill that missing value manually or using computer or remove the noise. All these things comes under data cleaning. So the answer is true. Of course, I got two questions. Share notes in WhatsApp group also. Yes, definitely. After completing our 9 days of program, I'll share the complete PPT to you in our WhatsApp channel. So that's what I said. Instead of sharing day-to-day PPT, I'll share you the complete PPT. So whenever in future, if you want to refer that, the complete machine learning from basic to the up to GenAI, deep learning concept, GenAI concept, everything will be in one notes. So I'll share at the 9th day of our certification program. Learning materials, the same thing. Anyway, learning materials, all the practical hands-on links I'm sharing already in that WhatsApp channel. You'll get all the links and of course data sets also for the practice. Just in the weekdays, weekends, you can practice those things and come with a basic knowledge of machine learning on Monday. Then we'll jump on to reinforcement learning and deep dive. Sometimes the users submit incorrect data in the compulsory fields to avoid personal information. This is known as disguised missing data. The answer is disguised missing data. It is not organized missing data. It is not characteristic missing data, or it is not coordinated missing data. It is called disguised. So just to disguise, they don't want to leak their personal data, so they'll give some incorrect data. That's why we call it as disguised missing data. So the next one is data integration is not a step in data pre-processing. Is it true or false? Yes, it is false. Data integration is a step of data pre-processing. Where data integration I already explained you to is just an aggregation process. Aggregate so many different databases into a complete database. For example, I have taken for that CT scan images. So to predict something, one CT scan is not able to predict the complete disease. So you have to merge all the database, CT scan images. So you will get CT scan images from different databases, and you have to aggregate everything and make it as a complete database. So then this answer is false. Next one is, collab files now. Yes, collab files already we have shared in WhatsApp channel. I think you are in that WhatsApp channel. So if you are there in WhatsApp channel, you go to WhatsApp channel and open each and every collab file with the name, that name of the algorithm we have shared. Is it okay? We have shared you the collab each and every collab link in WhatsApp channel. With the names it's there. Data sets also we have shared in WhatsApp channel. The next question is, which of the following is not a form of data transformation? So data transformation is one type of data pre-processing technique. So here the options are normalization, discretization, concept hierarchy, compression. So data transformation, that answer is compression. Compression is not a type of data transformation. So these are the answers for the quiz one. I hope everyone understood the concept of pre-processing, and I hope you people gave the correct answers. So now we'll move to quiz 2, the basic concepts of machine learning. So the first question is, what is machine learning? Machine learning is nothing but the autonomous getting of knowledge through the use of computer programs. Answer is C. And second question is, KNN is classified which type of algorithm? So I have explained you the types of machine learning that is supervised learning, unsupervised learning, and reinforcement learning. So in that particularly, before explaining the types of machine learning, I have explained you where that particular algorithm will be useful, whether it is a concept learning algorithm, whether it is a probability type of algorithm, probabilistic algorithm, or whether it is a whether it is like instant based learning algorithm, or whether it is distance based algorithm. So different types are there for a particular problem. Files are shared in WhatsApp channel. Base processing based program.
Okay, okay.
So we have image processing based concepts actually completely not covered in this session, but we will see that in our CNN. Anyway, in CNN, we'll take images, some classification hands-on session will take. For the CNN program, we'll take some images and I'll show you how to do some image processing technique. Completely image processing, completely that is a different area. That will take a complete session of 4 or 5 days to learn all the concepts of image processing. Here, that will not come completely. But anyway, in CNN, while dealing that CNN, convolutional neural networks, I'll show you how to filter, how to take the grayscale of how to take that filtration or some concept of image processing will cover there, but not completely. And of course, collab files we have already shared in WhatsApp channel. So particularly you tell me what type of algorithm you want. Then again we will share that same link in collab. I mean in WhatsApp channel. Already we have shared every day. Whatever hands-on here I'm taking that we already shared it to you. So next question will go. So here KNN is a instant based learning that I explained you why it is a instant based learning. At particular instant that will work, that will take action and that will work. And of course, which of the following is not a supervised machine algorithm? So I hope everyone answered for this question because so much time we took for the types of learning algorithms. So here K means naive Bayes, SVM and decision tree. So K means is not a supervised algorithm. It is an unsupervised algorithm. This is a clustering algorithm actually. Here the recordings of all the days along with PPTs. Okay, we will share you. We'll share you that PPTs. What's the key benefit of using deep learning for tasks like recognizing images? So here the answer is they can learn complex details. So while introducing you about AI, ML, and DL, the main differences when while discussing the main differences between AI, ML, and DL, I told you about what is the main, why DL is came into picture. Anyway, ML has so many advantages, but why DL came into picture? So the main reason is ML, we have to give the features. We have to tell whatever may be the algorithm, maximum features we have to tell. We have to give that features. But ML sometimes ML cannot able to understand the hidden features like inside in-depth features it cannot able to understand and in-depth insights it cannot able to see that the in-depth patterns it cannot able to understand when the image is a little bit complex or something. But DL we need not to give any particular so many features. Just a basic features we can give, and the deep learning concepts like neural networks will create some hidden features and it will divide that features into a global features, local features, all these things, and it will go into the depth of the data set and it will take the remaining features and it will take all the in-depth features. So it will create features. So it's easy to analyze the complex data. That is the main difference between ML and DL actually. It will analyze whatever may be the pattern, complex pattern, DL can able to analyze that complex pattern. It will see the in-depth of the data set. That is, so here the main purpose of DL is to analyze the data. The answer is to analyze the complex details of from the data on their own. Next thing is which algorithm is best suited for binary classification problem. So here the options are k nearest neighbors, decision trees, random forest, and linear regression. Uh, So the answer is here decision trees. Actually, binary classification, the best algorithm is anyway we can use k nearest neighbors and of course random forest. Random forest is uh, decision trees anyway. We didn't get time to discuss decision trees. Decision trees are also a type of supervised learning. So it's just like taking a decision using a tree structure. We will assume as a random node, a parent node first initially. From that, we'll create some child nodes. And from that child nodes, again, we'll create grandchildren nodes. And from that, all these tree structure, we will take the decision. So we will combine all any different more than one decision tree. Then we call it as a random forest algorithm. So anyway, we didn't get time to discuss these two. These two, and of course, SVM also. These three are one more important in supervised learning also. But if we will get again chance, then we'll see that algorithms too. But here, binary classification, the best algorithm is decision tree. It will give more accuracy compared to all other classification algorithms. What is the key difference between supervised and unsupervised learning? So supervised and unsupervised learning, the main difference is the labeled data and labeled data. In labels, if we give labels, that comes under supervised. If we not able to give any label, if you don't know the labels, then it will comes under unsupervised learning. And what type of machine learning algorithm falls under the category of unsupervised learning? So whether it is linear regression, k-means clustering, decision tree, random forest. So by seeing the answer, I think everyone can answer. So unsupervised learning here is k-means clustering. So wherever you get clustering, that comes under unsupervised. If the following statements is true about AdaBoost. AdaBoost also, it's a type of, it's just like a random forest algorithm. Ensembled algorithm, we call it as an ensembled algorithm. So ensembled algorithm is nothing but a combination of different types of algorithms. So instead of using a single algorithm, instead of using a single decision tree, so decision tree might have given some 60% of accuracy. But for my data set, I don't want only 60% of data, the accuracy. So to improve the accuracy, what I'll do, I'll take the same training data set, but at first time I'll take some parent node. The second time I'll change the parent node and again I'll do the program and I'll create one more decision tree. And third, again I'll take one more parent node and I'll create decision. So like that I have created 10 decision trees and combine and take the probability or average and finally I'll decide the final accuracy. So that is called random forest. Random forest is the best example for ensembled learning. AdaBoost also same thing. That is an ensembled learning. It's a combination of different types of algorithms. The thing is, so the answer is here. It is generally more prone to overfitting. Uh, Pruning is nothing but in decision trees. So in decision trees, the main problem is overfitting. Already I have explained you what is overfitting. So when you're creating decision trees, when you're creating some decision based on tree structure, you have to create all the nodes, parent node, child node. So each and every feature you have to create. Then only the structure will come, tree structure. So when you are creating like that, the tree will become very bigger size. But suppose you are creating a student data based on the tree structure. At some point of time, a student data, the parent node is a student. So when you are creating children, at point of time, maybe that children is some address, but that address is not useful after some time. So that branch is very useless for me. I have to cut it that branch. But if you not cutting that branch, automatically the memory storage will be increased and it will be waste of time and energy. And it's money also. So in that type of problems will occur in particularly decision trees. So for to reduce that things, so each and every iteration you have to check what are unnecessary branches are there and you have to cut it that branch. That is called pruning. So here he's asking, the question is whether the pruning will occur. Please share recordings for the past 4 days. Recordings we will share at the end of the certification program on our 9th day. That we will share. Any issues? Any issues means what do you mean about what you are asking me? I couldn't get it. Any issues means in the what way you are asking me to tell me any issues? Why do we categorize training and testing? Also validation. Training and testing already explained you. So if you have a data set, you are giving the data set to the machine and you are asking the machine to learn the relationship between the input and output, label and features. So it has learned something, it has trained something, and it has predicted. Then it has learned something and it built some model, some logic it has built between the input and output. Then you are giving a new input and it is predicted something. Then how do you know whether that is correct answer or not? You don't have any proof, so you don't know whether the machine is predicted correct answer or not. So to know that, we are splitting our data into two types. One is training data and testing data. So training data, we will keep only 70 lines, 70 some 70%. Only with that 70% only we will train the machine. Then the testing data we will not show to the machine. Machine don't know that testing data is available. After training, then we have already 30% of data. We have input and output there. So we will give only input from the 30% data to the machine. Then machine will predict some output. Then you compare that output with the actual output, whatever we have kept in our 30%. You compare the two outputs. Then the difference is called a loss. That loss, depending on that loss, you can tell whether your model is accurate or not. That's why we are creating training and testing. I hope you understood. Can you explain underfitting and overfitting? So underfitting is just like, I think one underfitting is giving a very less data to the machine. So for example, I have told you, you take some picture, dog image, cat image, anything. So I have to give some features like the eyes is one feature, the nose is one feature, the skin is one feature, skin color is one feature, and of course the tail is one feature. So four features you have given, and you have given some three types of dogs, and output you have created like this is Pomeranian dog, this is Alsatian dog, and some other dog. So these data you have given to the machine. And now the machine is trained and it is tested, everything completed. Then you have given a dog image of which is turned some turned back. Some other different type of dog image you have given to the machine. Then what do you think? Whether it can able to predict the dog image? Because only we have given three images. Only three images we have given. So almost we have given 3 into 4 features, like 12 features we have given. And we asked the machine to learn about everything about dog using these 12 images. So what do you think? The machine can able to learn? Can able to learn completely? No. Why? Because the machine cannot completely understand the data. Only whatever it learned from the pure data, that is not enough to undergo into the depth of the data and learn about completely about the types of dogs. That is called underfitting. So the data is insufficient to learn the relation between input and output. Now overfitting is Instead of giving that only 3 features, you are giving 30,000 dog images. 30,000 dog images you have given. Then what machine will learn so neatly? So everything it will learn. Now, if you show a fox photo also, it will treat it as predict as dog because it learns so much. So it creates a complex curve. While training, it creates a complex curve. It learns so much and it touches all the points of data sets and it creates a complex curve. So whatever you show now, it will predict that is a dog. That is called overfitting. Underfitting is insufficient data, overfitting is more data, giving more data. And how to detect categories, how to detect calories, fats, proteins with scan, a food item, which algorithm are used. If you want to classify that, which is, categories, like, categories means you have to go for a classification algorithm and uh, uh, if you want to predict some how much calories, how much fat number is there, some if this is increasing the fat, how much fat is increasing, like that process means you have to go for regression algorithms. That depends on your project. If you are only to classify from the food item, you want to see whether there are calories and of course there are fats and of course there are proteins available, yes or no. You have to go for a classification algorithm. Or if you want to classify how many calories are there, how many fats are there, how much amount of proteins are there, you have to go for regression algorithm. You want to group it. Similar items, food items are there. A similar food items will consist of a similar calories, similar amount of calories. So maybe 2 or 3 food items consist of only calories. Maybe 2 or 3 items are only consist of fat. So that you want to predict, and you go for clustering algorithm. So that depends on your project. What are advantages of KNN over SVM? For a medical image classification, how to select K value? First, K value is a random number actually. In the starting, K value is randomly we will select. First K, there is no rule to select only this value you have to select. So randomly we will select while going the algorithm, while training the algorithm, depending on that accuracy, you have to increase the K value. Actually, K we call it as a hyperparameter. So from outside, we will give the K value, we will increase the K value, we will improve the K value depending on that accuracy. And of course, SVM is completely different. KNN is just like by simply nearest neighbors, if similar qualities are there, you just grouping that elements. It is like KNN. SVM is completely different. SVM is mm, like a linear regression. We are just separating the features, feature 1 and feature 2 are input and output. We are dividing both with a single straight line, a linear curve or linear straight line. But in some cases, in real time, there won't be any 2D dimensionality. The dimensionality will be more, a higher dimensionality will be there. So if you are having the third dimensionality, then it is very difficult to see the third dimensionality properties, data sets. That cases, instead of going a straight line, we'll just go with the plane. I mean, the plane will divide that features and labels. So that is the concept of SVM. So SVM actually uses to uh, divide the features and labels with a plane. So the plane edges, we'll call it as the support vectors. The plane edges are completely close to the nearest neighbors, the points, data points. So that we call it as support vectors. So there will be a maximum margin. The plane margin will be maximum. So these two outer lines will be very close to the data points. So the separation will be completely clear. That will not happen in KNN. KNN randomly assumes. For image processing, actually SVM is the best algorithm to compare to KNN. There is no comparison actually. KNN is very simple algorithm. SVM is SVM can efficiently divide non-linear data sets. SVM is the best algorithm. And sometimes joining link is not working properly. Yeah, actually, it's some network problem. Today haven't joined due to this reason. Okay. Okay. If you don't understand any topic, then ask me now. We back to quiz now. The next question is artificially intelligent car decreases its speed based on its distance from the car in front of it. Which algorithm is used? So which algorithm do you think? The car speed and distance. One independent variable and one dependent variable. So of course we will use linear regression. When you have two variables and one is independent and one is dependent, definitely there is no chance you have to go for linear regression. The output is numerical and which of the following statements is fall about ensembled learning? So ensembled learning just now explained combination of different types of algorithm is nothing but ensembled learning. It's not a single algorithm. Maybe if you combine linear regression and logistic regression and some other algorithm KNN and taking the average of these accuracies and then taking the decision, then that is called a ensembled learning. Ensembled learning, it is supervised learning algorithm, it is unsupervised learning algorithm, more random algorithm can be used to produce a stronger ensemble. So answer is basically we treat ensemble learning as an unsupervised algorithm because we just combine all that algorithm, so we won't take care of the output. So we don't know actually output. Only we'll take care of the features and we'll try the features in different ways for all the algorithms and then we'll combine that accuracies. So we treat ensemble learning as a unsupervised learning. Which of the following statements is true about the stochastic gradient descent? So stochastic gradient descent, stochastic is one type of gradient descent. So gradient descent, yesterday I told you to, we will use gradient descent to minimize the loss, the difference between predicted and actual and predicted. So to minimize that loss, we will use a gradient descent. Particularly for the linear regression, we'll go for a stochastic gradient descent. So the correct answer is it processes one training example per iteration. So that is the answer for quiz 2. Then we move on to quiz 3. We will move on to quiz 3. Quiz 3 is completely based on supervised learning. So first question is which of the following is a supervised learning algorithm? The answer is the answers given here are k-means clustering, decision tree, PCA, and a priori algorithm. So answer is of course decision tree because the remaining 3 are unsupervised. In supervised learning, the training data set consists of the data set consists of both inputs and also labels. So input features and of course output labels both. Answer is C. Which supervised learning algorithm is known for its ability to handle both classification and regression tasks? So here SVM and random forest, KNN, linear regression. The answer can be a random forest and of course SVM also. SVM also can handle all the classification tasks and of course regression tasks. Both can handle. And random forest also can handle both. So any answer you can choose here, either A or B. The main objective of the classification algorithm in supervised learning is the main objective of the classification algorithm is to assign the input data to predefined categories. Our main aim of the classification algorithm is to classify the input features. Which supervised learning algorithm is based on the concept of nearest neighbors. That is KN. Nearest neighbors KN. Which algorithm is used to minimize the errors between the predicted and actual outputs in supervised learning. So minimize the predicted and actual output difference is nothing but minimizing the loss. That is gradient descent, gradient boosting actually. Which algorithm is prone to overfitting? Prone to overfitting means it is the answer is logistic regression here. Which supervised algorithm is an ensembled method that combines multiple weak learners to make predictions. So multiple weak learners to combines means it's a combination of different algorithms. So when you combine different weak learners and make it as a strong node, that is a random forest. So that happens only in the decision tree. So here random forest is the combination of so many decision trees. So that is the answer is random forest. The term supervised. A question I got: how to train machine to read X-ray images? Which tools required for data handling? Data handling we already seen in data pre-processing. And how to train machine to read X-ray images? How to train means what you want to actually what do you want actually? I mean, images reading is no completely about image processing. Up to now, we didn't go for any images. We are already taking data sets which are numerical or characteristics. When you go for images, that completely comes in neural networks only. That we cannot able to predict accurately using normal machine learning algorithms. So whenever we want to work on images, definitely we will work on neural networks. So when we are on Monday or Tuesday, we are going to see on CNN. There definitely I'll tell you how to train on images, particularly images. That may not be or may not be, maybe X-ray images, but definitely I'll show you how to work on images, how to do some data pre-processing techniques of images, and how to train the machine with particular image data set, and of course how to split that image data set into two. Everything we'll see in CNN. But for that, first you have to know some basic concepts of neural networks. Then only you will understand that. So it will take on Tuesday mostly. Monday it will be complete the basic concepts of DL. How to divide that first you have to know, and how to choose a neural layer you have to know. When you are going to teach us deep learning on Monday, from Monday we will start. Definitely we will start on Monday. Next question in quiz 3 is which supervised learning algorithm is based on the bias theorem? So answer is of course bias is there. So answer is of course naive bias. So this is about quiz 3. Now we'll move on to the last quiz which I have given you. Which of the following is an unsupervised learning algorithm? So here that is k-means clustering that I all you know. In unsupervised learning, the dataset consists of only input features. There won't be any output. Which unsupervised learning algorithm is used for dimensionality reduction? So yesterday we have discussed this, the PCA. Answer is PCA. So principal component analysis mainly used to reduce the dimensionality. The main objective of the clustering algorithms in unsupervised learning is the main objective of clustering algorithms is to determine the number of clusters. And of course, making it so many clusters, the main objective of any unsupervised learning algorithm is to make optimal clusters. So if you see k-means algorithm, first it randomly selects some centroids and it will create some clusters. Then after training, after going through the different iterations, centroid numbers will be decreased. So finally, after a particular number of iterations, you will get only 4 or 5 clusters. So the answer is we creating an optimal number of clusters, the main objective of unsupervised learning. And which unsupervised learning algorithm is based on the concept of nearest neighbors. So a bit confusing this question actually. Uh, Here he is asking nearest neighbors, but he is stressing like unsupervised learning. So we have to specify that unsupervised learning. So we should not mark it as KNN because KNN is a supervised learning algorithm. So here the nearest neighbors in unsupervised is hierarchical learning. So yesterday we have learned that we have seen that algorithm hierarchical learning which uses dendroids. And next question is which algorithm is used to identify patterns or relationships in unlabeled data? So here that is of course k-means clustering you can answer or association rule also. Main association rule mining is a type of unsupervised learning only to practice patterns. Mainly this algorithm used in market analysis. Just like our recommender systems. How many people are selecting this particular pattern? I mean, how many people are selecting a particular item? Suppose if you are taking a Flipkart, so Flipkart based on this particular association rule mining algorithm works on this particular algorithm. So immediately, for each and every second, it will predict how many people are liking a particular item, and that item will be clustered. That particular items will be clustered, and how many people are watching similar taste that people are clustered. So this particular algorithm is mainly used to create the patterns, and of course, it is mostly used in marketing analysis. Which unsupervised algorithm is used for outlier detection? And there is one more algorithm. It is isolated forest. Actually, many algorithms are there to predict the outliers. So already I have told you outliers. What are outliers? Outliers are nothing but whichever is not connecting with the data, whichever is not participating in the data, the points which are very nearer from that data set. We cannot able to cluster or we cannot able to group that particular data points with our data. So that's why that we call it as an outlier, because that we have to remove that outlier. Otherwise, the machine will confuse between the real data set and the outlier data set. So instead of building the model or instead of building the logic here, maybe it feels that that is the original data and it creates the model there. So accuracy will be completely less. So first thing in data pre-processing is remove the outliers. So to remove that particular outliers, the best algorithm is isolation forest. That is only used for anomaly detection or outlier detection. Which algorithm is used to find similar items or grouping similar data points together? So that is nearest neighbors. Which unsupervised learning algorithm is used for market-based analysis? So this I already told you. This association mining rule. So in that association mining rule, one type of algorithm, the type of association mining rule is appropriate algorithm. That is the answer. Which algorithm is used for recommender systems? recommender systems? Algorithm is recommender systems. It is the answer is collaborative filtering. Which unsupervised learning algorithm is used for finding the underlying structure or patterns data. So yesterday we have discussed this. Instead of only to reduce the dimensions, other than reducing the dimensionality, PCA works and to predict the underlying structure. Means yesterday I gave you an example also. If you are making a drug and you have some four ingredients are there, and you want to know for a particular drug what is the percentage of ingredient one and what is the percentage of ingredient two, and which ingredient is more effective in particular drug. So that percentage also you want. For that purpose, PCA is the best to predict all these things. The percentages, I mean, which feature is more effective on that particular label. So we call that as heat map. The reading of analysis of correlation between the features and of course the relation of feature and labels. So all these things we will normally represent by heat maps. So to read that heat maps, to understand that heat maps, the PCA is the best. So PCA not only reduce the dimensionality, of course it will tell the underlying structure of and the patterns of data. And the video is live mode only. Video is not stopped. Of course, these are the answers for our quiz, which I have given the last 4 days. So up to this, the session is clear, I think. If you still have any doubts or if you want me to tell any new topics, any particular topic in machine learning, of course, whatever time available for me, I try to cover most of the topics. Few are left. If time possible in the next classes, I try to cover all these things. Please provide notes of concepts. Yes, I'll provide the PPT. Definitely, I'll provide. Feedback link is published in your here. Please give the feedback link. Please fill the feedback link. So today's session is only for question and answers. If no questions are there, we will complete the class by 7:30. So I'll wait for 5 more minutes. If you have any questions or if you want me to tell like any feedback, like whether I'm going fast or whether I have to go a little bit slow, or do you want me to cover more of any topics, so just let me know through chat box. So if no comments are there, if everything is good, just give me that also. If no questions are there, we will end the class. We will provide the notes anyway. We will provide. We will definitely provide the PPT. No questions are there, then we will. Can you suggest some projects on CNN? Yes, while discussing the CNN, I'll suggest you any real-time application data set for lasso regression. Lasso regression. Actually, lasso regression, lasso regression and ridge regression is two types of regularization techniques. In yesterday's class, I just want to discuss this, but to show you particular lasso regression and linear the regularization methods means an optimization technique that is. So that particularly better to show you in deep learning models, because deep learnings normally are more effective for the overfitting. To reduce that overfitting, we will normally use regularization techniques. In regularization, particularly for if it is a regression problems, we use lasso regression and ridge regression. So while doing the deep learning problems, I'll definitely explain the regularization techniques, how to reduce that. I'll show you normal result using deep learning, and then after using the regularization technique, how the graph is deviated from the original graph. That I'll show you. There I'll explain you what what should be the real-time applications, how we can use the particular lasso and ridge for a particular application. Then I'll explain you. Please send us program manuals. Already program links I have shared you in WhatsApp channel, and there won't be any particularly manual. It's just PPT, and of course that in everywhere in that program you'll have all the comments section. Comments are there. So if it is importing library, at the starting I have given the comment also to better understanding. And some codes I have given at the side of the coding. Syntax, at the side of the syntax I have given the comments. More on medical images. So definitely, but we belong to the science engineering stream. So mostly we try to cover up all the fields, not only medical actually. So if I take the linear regression, I have taken some age and salary straight. If I am taking logistic regression, I cover that medical health system. And while covering the KNN, I have considered the IRIS data. So as an engineering stream, I try to cover from all the streams, not only for medical actually. So, but in anyway in CNN, while doing CNN, we have to take images. So we'll take some medical images and we'll try to do the project on that. Like the way you teach us, ma'am. Thank you. Madam, please make a session on image handling. So that's what again and again I'm telling. This session is completely a combination of ML, DL, and GenAI concepts. It's not only particularly for images. It's a combination of ML, DL, and GenAI. Actually, ML, normally, frankly speaking, it will take some 6 months or 1 year subject if you want to learn ML completely. But the three concepts I have to cover in 10 days. So in that only particularly trying to do more work on image handling is impossible. So we'll try to cover that in next, if possible, next FTP session, we'll try to cover that also. But anyway, while doing CNN, I'll try to cover how to deal with images. That I'll show you definitely. Please share the video sharing as it requires time for us to practice to learn. Yes, video recordings will be shared to you at the 9th day of certification program after completing the 9th day. All the sessions should be completed, then only you'll get the recordings. Not each and every day you won't get. Take some example from Kaggle and give us demo, ma'am, for medical images classification. That's okay. While doing CNN, we'll do that. Anyway, that if data sets, whatever data sets I have considered, I considered from Kaggle only. There is no real data set. From Kaggle only, I have downloaded the data sets and I showed you the program. Will there be quiz today? No, there won't be any quiz today. From Monday onwards, again, you will have the quiz sessions. Today is just question and answer sessions. Due to some technical issues, I left yesterday class. Is it okay? We'll get certificate. Yet, if you have 80% of attendance and of course 75 marks if you gained in the last certification exam. On the last day, we'll have an exam, certification exam. So if you should get a 75% of that exam and 80% of attendance should be there. Then you'll definitely get certificate. So I hope everything is clear today. Now I'll take a break and I'm going to end this session for today. And Monday we will be ready to dive into the deep learning concepts. And so practice more on weekends. Okay then. Have a nice day and thank you.